Welcome. This is the first live session of this kind. I would really like to show you and maybe just tease you about the many different things that you could do with Python with OpenSees. Okay. I am a big fan of Tcl. I love the Tcl language. I grew up learning OpenSees using Tcl. But a couple of years ago, I don't know how it happened, but I started playing with the Python version in OpenSeesPy when Professor Scott and his postdocs developed it. And I've kind of gotten excited about it because there's just so many other things that you can do. And, you know, OpenSees is really just one tool in our framework. And I'm a big fan of having a continuous framework where everything is all in one place. You're not working with one software, one place, translating it, and then you forget, wait, did I update this? Did I update that? And so I'm really enjoying being able to have one platform that can help me to do it all. It doesn't do it for me, but it helps me to do it all. So I wanted to introduce the different things that I've learned about what you can do with Python. A lot of it, I have to admit, is I've learned from the researchers and postdocs and students at the OpenSees Cafe. We meet weekly. If you guys want to join, it's a great place to discuss questions, topics related to OpenSees and earthquake engineering and things like that. But they're seeing how other people have used OpenSees. They've taught me all these little tricks and new things and given ideas. And so that's my goal today. My objective for my workshop is to teach you enough to leave you with more questions and answers. And you know that those of you who know me, that's my pitch is, you know, you leave a meeting with me, you always leave with more questions and answers, but in a good way, because I want to get you guys going and thinking. I would love it if this becomes an interactive. Stop me, ask me questions, provide insights. I'm still learning all of this. Every day I learn something new. So let's get started. Here's the outline of the workshop. I've kind of broken it up into different parts. And as I was working on the future parts, I've added and edited. So this outline actually changes through this presentation. But what I'd like to do is first kind of give you an introduction as to why OpenSeesPy, comparison of the Tcl versus Python interpreters. I'm not trying to convince you that the OpenSeesPy version is better. I want to educate you on the differences. You will see a lot of material out there. You know, all the examples, manuals that I've developed, all the videos that I've done are all based on Tcl. But I wanted to get across to you that that's just the language. It's just the very, very top layer. OpenSees is the same, whether you communicate with it in Tcl or in Python. And sometimes there's advantages to one or the other, and it's very easy to translate from one to the other as well. What I like about Python, as I've said, is that you can integrate a lot more into it. Okay, and so that's what I'm going to talk about in the very first part. Second part, I'm going to show you some nice things and introduce you to different concepts of Python libraries and packages, what makes it so fun to play with, because it's very easy to integrate packages. Then I'm going to talk about, you know, arrays and data frames, which are just data structures in Python. We're going to talk about model visualization, which is really it's almost the big, easy to see power of integrating the visualization with OpenSeesPy. But I actually think that the libraries are that much more powerful because it allows you to, there's libraries on distributed computing, there's libraries for Monte Carlo simulations. And so just knowing that that is out there, and I'm going to show you where you can find these things, helps you to expand the scope of what you're doing with OpenSees. And then we're going to look at some Brainery bytes, which are examples that I've already developed in Python, show you how they work and what you can do with them. And the goal here is to empower you to be creative with what you can do with Python. Okay, I'm not giving you a lesson on Python itself, but I want to make you curious to learn Python. A lot of the semantics is all online. There's lots of YouTube videos, there's lots of online resources and things like that. Okay, any questions or comments anybody has at this point? We're all good? Okay, so let's get started. I'm gonna open up the gallery on my other screen so I see you guys. Anybody? Christian is my gauge that he nods when I can go on, but if anybody puts your arms up, go ahead. All right, so thank you. How many of you are already familiar with OpenSees, as in you've started it, you've opened it, you've played with it? Okay, Philip. Okay, very good. I see a few thumbs. Okay, so, and how many, here's the big question is, how many of you guys are working with Tickle? And sorry, I have two screens, so I look at different places. How many of you are working with Tickle, and how many of you are working with Python? So first of all, who's working with the Tickle OpenSees? Okay, no hands. How many of you guys are working right now, working with Python? Okay, and how many of you guys are planning to work with Python? The rest of you guys. Very good, 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 good. All right, so my job here is not to convince you, because that's what you're doing, but to really just, I didn't know you could do that kind of meeting today. Okay, and again, these are all new things to me, and so if you've got feedback or more experience than I do with this, let me know. Okay, so first of all, OpenSees, and why OpenSees? And that's always the question. And OpenSees it's versatile. It's a framework. It's not a program, and it's an open source platform, which is evolving every day. And that has its pluses and minuses, of course. It's not an established, it doesn't have an infrastructure of, thousands of developers that fine tune all the details. But what's powerful about OpenSees is actually this user interface. Everybody complains that, oh, OpenSees doesn't have a user interface. Well, it actually has a better open user interface than traditional programs that just have a basic graphical user interface, okay? So any program needs a user interface. Many of them, and most of them have been developed at universities and research institutions, and they're based on an input file. And then oftentimes they'll develop a graphical user interface on top of that generates this input file. So GUIs are wonderful. They're very user-friendly. They're great for visualization capabilities, and it's very easy to go in and you can edit your model and you can visualize the changes. Working directly with an input file, OpenSees, many people have developed many different GUIs for OpenSees. Heck, I've developed one myself. But working directly with the input file itself, actually, it appears to be unfriendly because you don't quite have the visualization, but it's so much, it may not be easy to edit, but it's fast to edit, okay? You can go in and you don't have to go in and reach that one element whose properties you have to change. You just open up the input file, find the line, and make the change. Not only that, but then you can duplicate this file and make changes, so it's very easy to expand your input file. It's easy to then modify it. Oh, I've got a different building. Well, I'm going to start with the core materials and properties that I have. So GUIs are very 90s and they're wonderful, but working directly with an input file itself is a lot more powerful. And before OpenSees, and I often deal with programs like OpenSees of pre-MATLAB, you've got a fixed input script, and you've got, certain, each line specifies something, you have to delimit it, but it's got fixed values, okay? When high-level interpretive languages came in, such as MATLAB, it gave us the power to now program your input file. And so that is the strength of OpenSees, is that now you've got programmability, and that's the most valuable power of it, is the programmability of your input file. Okay. And I know that you guys are already using OpenSees, so you've already been sold on that, but that's something to really keep in mind actively. And that's why I'm emphasizing it, because every time that you're writing some input, I want you to think, can I put this into a program? Can I put this into an algorithm? Can I create a little script that then I can use again and again? What's the power of writing the scripts? One is it's easy, but two is it's a piece of code that you've tested. And so it's a piece of code that now you've tested it once, you validated it, and so you can use it in different parts, and you don't have to worry about errors in that piece of code, as well as having to debug it again and again. Okay, so anytime you can write something into an algorithm, I want you to be active about it and do that. Even defining node, okay? Even something that simple is a good idea to do it. And then OpenSees in the days, they put their bet on Tickle TK. TK is a wonderful UI program. It's got great widgets and things like that, but it's a lot more manual. And so at the time they chose Tickle, when Python is actually the language that's picking up more, just because it's just easier to integrate, and I'll show you why. Okay. And so what's unique to OpenSees and integrating this interpretive language is that we're able to interact with the program, and you're able to develop an adaptive input algorithms. Okay, very important, and it's something I want you to take advantage of. Many times you'll see just, lots of numbers and just really long input files, when, hey, maybe I can write a program to do that so that then I can expand it to something else. Okay, or you can do it, okay, first I'm going to build an elastic model, right? This is the advice that Michael Scott always gives. Professor Scott always gives is, test this elastically. Well, now you could put an if statement. If it's elastic, then use elastic properties. If it's not elastic, then use the inelastic properties. So in one code, you can adapt it for depending on what you want to test and what you're doing. Second part is the analysis. Because you're working interactively with OpenSees, if it says, hey, I didn't converge, you can implement these adaptive, you can reduce the time step. You can try different algorithms. Typically, it's the time step is the most powerful thing that you can do. If you're having troubles with the algorithms, I would first check your section and your properties. Okay, so this is wonderful. And this is something we all know about OpenSees, that you can write these scripts. You've seen my examples manuals, and they're all there. By being able to integrate this now almost live with OpenSeesPy, you can do a lot more. Okay, you can do more interactive input, because you can say, okay, I've defined the materials, and I'll show you in the scripts. And I'm going to look at the materials, and I'm saying, oh, this doesn't quite look right. And so you can do it right in your script, plot the material behavior. Oh, that doesn't look right. And you correct it almost in real time. You don't have to, okay, here's my input, run it, then go to MATLAB, post-process my results, look at the material behavior. And then you don't even do that. Okay. Most people will then just they'll build a model, and then they'll go do a pushover analysis and say, hey, my pushover analysis doesn't work, because you're missing the in-between. And so that's not interactive model development. By being able to, after a few lines of defining the materials, is, okay, now plot the stress strain response. And you look at the stress strain response, now you can identify, oh, there's something wrong with my steel, there's something wrong with my section. And so that's really, it's the advantage of doing it in Python, but it's and if you do it once and you write the script to do this, it just becomes part of your script. And then it automatically becomes part of your documentation. I don't like to write documentation, And so with Python, especially with Jupyter Notebooks, your program itself becomes the documentation itself. And so as you make changes and you add things, it all just becomes in real time. And so as much as most people, oh yeah, I can do this in Python, think about that interaction that you can bring in and visualize the material strains as you do the analysis, as before you do the analysis, as you develop your model. Okay, and that's really that's what I find that I'm doing more with OpenSeesPy than I was doing with the Tickle version. Is I was not patient enough to look at the intermediate results. I just went right to the end, and then you're like, wait, what am I missing in between? And so OpenSeesPy allows you to do this, which kind of has taken me to the next slide through that, okay? And so take advantage of being able to communicate with OpenSees. Display the model. Before, just, displayed me just the nodes, right? Show me where the elements are. And as you build the elements, you just press enter and you can visualize that, as you make edits, your program grows. And so then why Python? Well, everybody's now learning Python. It's, somebody was even texting me on Facebook that he wants to learn it as a hobby. Okay. And so it's great because it's a language. If you're going to learn something that helps you with OpenSees, but also with other projects. I'm using Python for my ground motion work, just because I've integrated in the plotting and the things like that. And then I can say, and then I can bring in OpenSees and I've already done all the ground motion work already with Python. So it's easier to integrate. I don't like going from one program to the other because anytime there's a human interaction, that's a chance for error or just inconsistencies. And that's what's wonderful about what you're doing with OpenSees and integrating it with Python. Let's see what I wrote on here. So Python is based, it's based on this open source framework where developers as well as users can easily develop code and share with others. Okay, so you'll see that there's a lot of new libraries that are coming out that people are developing to, even I've developed my library and put it up for public use. And so it's a very active community and it's always evolving and getting better and better. And so that's a great place to be because it's a good environment as you move forward. We're not just trying to get our PhD done. We're trying to really learn and understand things. So there's so many libraries and you can do one yourself. You can integrate the graphical capabilities and work interactively. And Jupyter Notebooks. How many of you guys are using Jupyter Notebooks? Okay. I'll show you the Jupyter Notebooks because I like to do a lot of my work in the Jupyter Notebook, mainly because you can integrate HTML into it and figures. So as I said, it just becomes a nice looking document. And what's nice about Jupyter Notebooks is that you can now share them with, you can actually create a web app. And that's what I've done. If you've heard of the Brainery bytes, and I will show you, is if you put your Jupyter Notebook in GitHub, anybody else can open it up and visualize it, and it's documented, and you can execute things with it. So it becomes a web app that's easy to share with others. So that's, I think there's a lot of power to that, especially because now you're not sending code. People just access it directly. So as you update it, people can, follow the updates. So Jupyter Notebooks have a lot of fun. And what's nice about Jupyter Notebooks is that you can create widgets, so pull down menus and options. And so even for yourself, it's like, instead of having to go in, this case is elastic and typing it in, you can put that into your notebook and make that be a pull down menu. Nice thing about pull down menus is there's no errors in typing because it's people, pull down choices. And so that's really powerful or you can go and click and run it. And so it makes your work very user friendly for others as well as for yourself. Okay, so I use Jupyter. I use Jupyter Notebooks a lot for when I just kind of want to visualize things. I think I do more stuff. Like when I'm developing my code, I do it in Jupyter Notebook. And then I might save it to a Python if I need to send it to run, many, many analyses. And so it's a great development environment. Yeah, and it becomes self-documenting. So, and there's some features, there's some things that work that don't work in Jupyter Notebooks. I can't get the distributed computing one to work, but I think it can be done. But then there's other programs such as Folium, which is a great interactive map program that only works in Jupyter Notebooks. So that it's the two tools to use.